In this session, we'll discuss the electromagnetic spectrum. So this whole exercise is related to the topic electromagnetic spectrum. Basically, what are electromagnetic waves, which can travel through vacuum, can transfer energy. So it is important that you should know the order of the electromagnetic waves. So the first multiple choice question, light from a sun. So sun is emitting out visible, the only part which our eye is sensitive or we are able to see, that is a visible. So the sun is providing the visible light as well as the ultraviolet and the infrared or heat radiation. So visible is there, ultraviolet is there, and infrared. All the three radiations are there from the sun. The only part which you are able to see, violet, and the visible one which we can see, and which include violet, indigo, blue, green, yellow, orange, and red, where violet bends the most and red bends the least. The bending of the light depends on the frequency. The one which will have a higher frequency will bend the most. So when we compare ultraviolet, infrared, and visible, so ultraviolet is having the highest frequency and infrared is having the shortest frequency, and visible is in between them. So the two rays, in this case, the ultraviolet will bend more than violet, and infrared will bend less than red. So in the question, a thermometer is placed, and thermometer is used to identify or measure or detect the heat radiation. So a thermometer is placed at P, and that shows a large temperature rise. So why a large temperature rise? Because thermometer can detect which radiation? It can detect infrared radiation. That's why A is the right answer for this. Is it clear, this one? In question 2, we have a white light. White light is a combination of a 7 color which include violet, indigo, blue, green, yellow, orange, and red. Which is a correct diagram, as a white light is passing through the prism, so dispersion happen. This is wrong. Why? Because it happened when it entered. Why this one B is wrong? Because when we draw the normal, it bent towards the normal as the speed is decreasing. And when we check C, first part is correct, but the second part is wrong because it shows it bent in wrong way. So that the correct answer is D. So when moving from air to glass, it bent towards, and then moving from glass to air, it bent away from the normal. The diagram represents the dispersion of a white light by a prism. Why does the dispersion occur? What is the reason for a dispersion? Because there is a change in the speed. And for violet, there is a greater change in speed compared to red. So speed of violet and red both decreases, and the speed of the violet decreases more than the red. So all the waves are not traveling at the same speed in the glass. That's why the violet bends the most and red bends the least. So due to the change in speed, and there's a greater change in speed for violet as compared to that of red. In question 4, different parts of electromagnetic spectrum are used for different purpose. Below are 4 statements about the parts of electromagnetic spectrum. Infrared waves or heat waves are used in television remote control. That's true. Radio waves are used to transmit television pictures via satellite or from the satellite to Earth. That's wrong, because the radio waves are not used. Actually, microwaves are used for satellite communication. Ultraviolet waves are used in intruder alarm. That is also wrong. Infrared waves are used for intruder alarm. And X-rays are used for security check. Yeah, that's true. So statement 1 and statement 4 are the right one. That's why B is the right answer. In question 5, which list shows electromagnetic waves in order of increasing frequency? So when we write the spectrum, we have radio, micro, infra, we can write IR, visible, the only part which are eye sensitive, UV, ultraviolet, then X-ray, and then gamma. So moving from radio to gamma, what we will observe? We'll observe the frequency will increase. So in this order, from moving from radio waves to gamma, the frequency increases. Gamma is having the highest frequency, greater energy compared to that of radio. So the correct order of increasing frequency. So visible, after visible, it should be ultraviolet, but they did not mention. It's not necessary. They did not. They can skip, but it should be in order. Should be correct. So we have visible. That's correct. Then we have X-ray, and after that there is a gamma. This is a symbol for gamma. So A will be the right. Why B is wrong? Because first it is written visible, then gamma. But it should be visible, X-ray and gamma. X-ray, gamma and visible. So that is totally wrong. And gamma, X-ray, visible. This order is correct, but this order is decreasing a frequency. But in the question they are asking which is the order of increasing frequency. Is it clear, this question? 5. Then the MCQ is there related to electromagnetic spectrum, order of increasing wavelength. Increasing wavelength is opposite, because increasing frequency, if frequency increase, the wavelength decrease. So it is opposite, that when we write, this is the order of increasing the frequency. But if we say increasing the wavelength, order of increasing wavelength, so it will be other way around. It starts with a gamma, then ultraviolet, then X-ray, visible. So what are the parts which are missing? Gamma is there, X-ray, and between X-ray and visible we should have ultraviolet. After visible, and between visible and micro we have infrared, and R should be radio. So P should be ultraviolet, Q should be infrared, and R should be radio. That's why C will be the right answer. Which row shows the nature of light waves? Like all electromagnetic waves are transverse. So light waves and X-ray, they are transverse, and sound waves in which the particle vibrate parallel. So sound waves are longitudinal. So light waves are transverse, sound waves are longitudinal, and X-rays, all electromagnetic, even it is micro, ultraviolet, gamma, they all are transverse in nature. The visible light has a frequency which is 5 into 10 power 14. So this is a frequency of the visible light. The light which we can see, which is having a frequency 5 into 10 power 14. There is M which is having a lower frequency than visible, and there is N which is having a higher frequency. The frequency of M is 5 into 10 power 6, which is less. And for N it is 5 into 10 power 15. So the one which is having higher frequency than visible, the light rays which are having a higher frequency than visible, that can be ultraviolet, UV, it can be X-ray, or it can be gamma. And the one which is having a lower frequency than visible, infrared, micro, or radio. So M can be infrared, micro, radio. So M can be infrared, micro, radio. So either A will be answer or B will be answer. Then N can be ultraviolet, X-ray or gamma. So it cannot be infrared. So it is B is the right answer, because ultraviolet M can be ultraviolet, X-ray or gamma, but the only option in which is N is ultraviolet between like A and B. So ultraviolet is the right answer, because it is having a higher frequency compared to that of visible. The diagram shows four sources of sound which produce a longitudinal. Longitudinal means particle vibrate parallel to direction. Here, when we disturb the water surface, the wave is a transverse. All electromagnetic waves, radio waves, they all are transverse in nature. And sound from a loudspeaker, it produces vibration of the particle, and that vibration is parallel to direction of the wave. And light waves, it is transverse in nature. So the option C is the right answer, in which the particles vibrate parallel. The table shows different types of waves in electromagnetic spectrum. Where do all the wave travel at the same speed? So they all travel same speed in a vacuum, which is 3 exponent 8 or 300 million meter per second, or we can say 300 meter per second is there, or 300 million meter per second. The sun emits infrared radiation and light. So sun is emit, even ultraviolet is there, but that ultraviolet, most of it is stopped by the ozone layer. So on the earth we are able to receive most of heat radiation, the infrared and the visible. Infrared will have a longer wavelength relatively compared to visible one. So if the light from the sun takes 8 minutes, how much time infrared will take? So if the visible light is taking 8 minutes, the infrared will also take 8 minutes, because they're traveling at the same speed, which is 3 into 10 to the power 8 meter per second in a vacuum. So that's why both will take the same. And when we compare the wavelength of infrared, it will be longer. So longer wavelength compared to that of visible light, but time it will take same, because they are traveling at the same speed in a vacuum. Is it clear, this question 11? Then scientists describe light being monochromatic. The term monochromatic means light which is having only one wavelength or one frequency. Here all the waves travel in, all the electromagnetic waves travel at the same speed in a vacuum. That is the thing. In vacuum, because between sun and earth there is a vacuum, that's why they all travel at a same speed. So the term monochromatic means light which is having only one wavelength, or it is having single frequency. So light with a single frequency or light with one wavelength, that's why A is the right answer. The term mono means one. Like when we use the term mono, it refers to one. So chrome is from color, but the scientific definition is not light of single color, it is light which is having only one wavelength. Which statement is not correct? So when we check for question 13, the speed of a longer wavelength infrared radiation in vacuum is greater than shorter wavelength. That is not correct, because they all have the same speed. The speed of a microwave in air is about 3 exponent 8. That's true. The speed of the gamma rays, because look, 3 exponent 8 meter per second, I can also write as 3 into 10 to the power 5 kilometer per second. So both can be written in the same manner. It won't make difference. So 3 exponent 8 or 3 exponent 5. But the only difference here, this is meter per second and this is kilometer per second. But both are the same values, because both are refers to 300 million meter per second. An X-ray emitted by supernova explosion reached the Earth same time as visible light. Like when the stars are decaying or formation of a star, or basically supernova is refers to explosion which leads to formation of multiple stellar objects. So if it is emitting out X-ray and visible light, so both will come to us in the same time because they are all travel in the same speed. So in the question, this is the right statement, but in the question we want to identify the wrong statement. So A is the wrong statement. Is it clear? Question 13. Then the diagram shows which diagram correctly shows the path taken. First thing, why A is wrong? Because when they enter, they should spread. B is also wrong. So either C can be answer or D. But when we check the colors, violet, indigo, blue, green, yellow, orange, and red. The violet means if it blue will bend more and red will bend least. So here it is wrong because the order is wrong. So what is the correct answer? Blue will bend more and red will bend the least. That's why D is the right answer. So the one which is having a colors also have like light in colors is also having a frequency. So violet is having the highest frequency in terms of colors and red is having the shortest frequency. So violet bends the most and red bends the least. So colors which are closer to violet, they will have higher frequency than the red. That's why they will still bend more. So which diagram shows the correct order of electromagnetic spectrum? Radio, infrared, visible, ultraviolet, X-ray, increasing wavelength. That is wrong, because in this order the wavelength is not increasing, the wavelength is decreasing. Radio, ultraviolet, visible. So even this is totally wrong, because between radio and visible, either it should be a microwave or an infrared. So this is totally wrong. X-ray, ultraviolet, visible, infrared, radio, and that is an increasing wavelength. That is true because when we move towards the radio, the wavelength is increasing. And in D, the order is totally wrong because between visible and radio, you don't have ultraviolet. Either it will be infrared or a micro. So C is the right answer. Which type of radiation lies between a visible and micro? So when we write the electromagnetic spectrum, we have, if we say gamma, X, UV, visible, the light which we are able to see, and visible include violet, indigo, blue, green, yellow, orange, and red. Then there is IR, then there is micro, and then radio. So between visible and micro, which radiation lies? It lies IR or infrared. So it is very important that you learn the order and both ways, like increasing of frequency and increasing in wavelength. So the student shines a narrow beam, he sees different color. So the violet, indigo, blue, green, yellow, orange, and red should be there. So the one which bends the least should be red. X should be red. So X should be red. So either B will be answer or C will be answer. Then When we check blue and yellow, like Z should be blue because the blue bend more than the yellow. As you can see, blue is here and then yellow. It is violet, indigo, blue, green, yellow, orange, and red. So red, yellow, and then blue is there. So red, yellow, and blue. That's why C is the right answer. Is it clear, this question? Then which diagram shows a dispersion? Dispersion means spreading of the wave when it moves. A white light, when it moves, it spread into colors because there is a change in the speed of the component of the white light. So C is the right answer. Which group contain only transverse wave? All electromagnetic are transverse. Infrared transverse, light transverse, but sound is not transverse. It's longitudinal. Infra, light, and UV all are transverse. Infra, ultraviolet, but sound is not. Light, sound is not. Ultraviolet is there. So B is the right answer, which include all the transverse wave in which the particle vibrate perpendicular to direction of the wave. Then question 20. The table gives common uses of three electromagnetic. Which row is correct? For satellite television, we use micro. For terrestrial, like non-satellite, we use radio. And for television remote, we use infrared. So micro, radio, and infrared, that's why B is the right answer. So as we already discussed the uses of these electromagnetic radiations, which type of electromagnetic radiation is used in airport security? Like how they scan or how they check your luggage. So they're not passing infrared, not the micro, not the radio. Actually, it is X-ray to able to detect the metallic object. X-ray cannot pass through metals or bones. Then the diagram represents the electromagnetic spectrum. Some regions have been labeled A, B, C. Some labels are missing. Which region should be labeled as infra? So after radio, we have micro, then infra, then after visible, we have UV, and then X. So infrared is actually B. Radiation from which part of electromagnetic used in a remote control? That is A. Microwaves are used for satellite communication, radio wave, terrestrial communication. Ultraviolet are used for sterilizing or kill bacteria or used in a fluorescent lamp. Bulbs are there. We use this ultraviolet. Laser is a source of light with a single frequency. So what is the term whenever a light is having a single frequency? What we call that as a monochromatic. The term mono means light with one frequency or one wavelength. In 25, the visible light, X-ray, microwave, all are electromagnetic. Which statement is correct? In vacuum, micro travel faster, that is wrong. In vacuum, micro travel at same speed as visible. So micro and visible both travel and have a shorter wavelength. That is wrong because micro wavelength is longer. So in vacuum, X-ray travel faster. That is also wrong. Or in vacuum, all travel with the same speed. In vacuum, X-ray travel at same speed as visible, and X-ray is having a shorter wavelength. That's true. Shorter wavelength or a higher frequency. So that's why D is the right answer. Then the structure question. Figure 7.1 shows a part of electromagnetic spectrum State one type of radiation that has a higher frequency. So which one is having the higher frequency? We can say gamma or X-ray. Only one we have to say, so that's why we are saying gamma rays. Then which is having a longer wavelength than visible. So longer wavelength than visible, because this part of infra, micro and radio part, they have the longer wavelength. So what we'll write as the radio waves. Even I can write infra, that is also a right answer because they all have higher wavelength than. Some gamma emitted from the radioactive source is having a speed of 3 into 10 power 8 and wavelength is 1 into 10 power minus 12. What is the frequency? So we use a wave equation. V is equals to f lambda, that is speed of the wave is equals to frequency multiplied by wavelength. So speed of the wave is given 3 into 10 power 8, frequency we don't know, and wavelength is 1 into 10 power minus 12. So if we need frequency, it will be 3 into 10 power 8 divided by 1 into 10 power minus 12. So when we solve this, it will come out as 3 into 10 power 20, and the unit of the frequency is hertz. So this is a wave equation which is valid for all kind of waves. State the approximate speed of infrared in air. So all, like in a vacuum or air, we consider in air it is slightly less, but we consider all have the same speed, which is 3 into 10 power 8 meter per second, or you can say 3 into 10 power 5 kilometer per second. So 300,000 kilometers every second these radiation can travel. Question 2, figure 6.1 shows a white light at a P. Red light is shown. On the figure, draw a complete path for a red. So for red, we have to complete a path, so it will bend away. And then the whole path for a violet. So we want to draw, violet will bend the most. So this will be the path which is taken by the violet. Then the next part, the angle of incidence and angle of refraction are given. At angle of incidence is given and refractive index. So angle of refraction is needed. The light is traveling from air to glass, so refractive index is given by a formula sin I over sin R. So refractive index is 1.52, sin angle of incidence is 40, and angle of refraction we don't know. So it will be sin 40, sin R is equals to sin 40 divided by 1.52. So we have to find the value for sin 40. So to get the value for sin 40, as a formula for refractive index, when it is moving from air to glass, so it is sin angle I over sin angle R. So refractive index is 1.52 and it is sin 40 divided by sin R. So sin 40, what is the value for sin 40? We should take in degrees. So sin 40, that is 0.64. So this is 0.64. So 1.52 is equals to 0.64 divided by sin R, or sin R is equals to 0.64 divided by 1.52. So this value divided by 1.52, that's equal to 0.42. So when we divide, it means the value of sin R is equals to 0.422. But we need R only, so R is equals to sin inverse 0.42. So sin inverse 0.42, so sin, but we need inverse of that. So we have to invert sin of the answer, the last answer which we got. So it will be 25 degrees. So when we solve for R, it will come out as 25 degrees. So this will be the angle of the refraction as we solve. So we'll write as 25. Then state the approximate speed of white light at P and red light at Q. So at P, the white light is in a air. So whenever it is moving in air, the speed of the light is 3 into 10 power 8. When red light is at Q, it is also in air. So what will be the speed? 3 into 10 power 8 meter per second. So these are free marks. This is 3 into 10 power 8. This is also 3 into 10 power 8 meter per second. Then this is related to sound, consecutive wavefront. Part B is there. On the figure, label the position of a gamma, visible and radio. So where we'll find gamma? Gamma is before X-ray, like higher frequency, and then visible. Ultra is there, but we don't have to write ultra. We have to write visible. So here we can find visible. Infra is there, and after infra, micro, and after micro we'll have radio. We don't have to mention UV and micro as they did not ask for that, so it does not have any mark. State which of three types of wave has the lowest frequency. So which one is having the lowest frequency in these three? The gamma, the visible, or the radio? So the radio is having the lowest frequency and the highest wavelength. Approximate speed of radio wave. All the waves, they have traveled 3 into 10 power 8 meter per second or 3 into 10 power 5 kilometer per second. Then this question, the following list contain names of type of energy transfer by mean of wave. Which of these is not electromagnetic? So gamma is electromagnetic, infra, radio, T, micro is, but sound is not electromagnetic. Sound cannot travel through vacuum. So the correct answer is sound. And what is the nature of the sound? Sound is longitudinal. Nature means how the particle, and mechanical. What is the meaning of mechanical? Mechanical means it need a medium. Like in a vacuum, it cannot travel. That's why we call mechanical. The remaining names in the list are all the but one of the name is missing. What is the missing here? We have gamma, infra, radio, visible, ultraviolet, but what is missing? UV or ultraviolet is missing here. Then a television emits. So we have the frequency, we have the speed, we need wavelength. So V is equals to F lambda. So V is the speed, which is 3 into 10 power 8. F is a frequency, 2.5 into 10 power 8, and lambda is the wavelength. So it will be 3 into 10 power 8 divided by 2.5 into 10 power 8. We'll get its wavelength. So 10 power 8 cancel with 10 power 8. And basically it will turn out to be 3 divided by 2.5. So it's 1.2 meter. Then this question, figure 7.1 shows a monochromatic. Monochromatic means light with a single frequency or wavelength. State what is meant by monochromatic. What is the definition of monochromatic? It means a light with single wavelength or light with one wavelength. That is called monochromatic. For this red light, the refractive index, calculate the angle of refraction, that we can use a formula to work out. Then without measuring the angle, draw approximate path for ray. So we don't have to measure the angle. So it will bend towards the normal. And then we draw the dotted normal, and this, when it is coming out, we'll also draw the normal here. So moving from air to glass, sorry, glass to air in the second part, it will bend away from the normal as the speed increases. And keep one thing in mind: for a parallel glass block, side glass block, the ray which enter and the ray which leave should be parallel to each other. Then this part is related to refractive index. We already have discussed that. Using a ruler, draw approximate path for a violet and label that as V. So first we drew the path for the red, but now we have to draw a path for violet. Violet will bend more when it enters the glass, and this will be the approximate path for the violet. So we have to label that path as V, and the path of the red was letter R. Because the violet bends the most as its speed decreases more than red. A ray of a green light along the same path as red, this is a red light. Like when a red light is, a white light is there and they are giving you the path of the red light. On the figure, draw the path for a green light. So we have to draw the path taken by the green light. So it will bend more than red. So this will be the path taken by the green light. So how you can identify bending more or less? So remember the order: violet, so violet, indigo, blue, green, yellow, orange, and red. Violet will bend the most, red bend the least. So because we are talking about green, so compared to red, all of the rays bend more than red when they enter the glass or changes the medium. So this was exercise related to electromagnetic spectrum.